So today is our session on routing policy. Yesterday we have seen DHCP and MAC. This is not in the course syllabus of JNCIA, but routing policy and firewall filter, these two topics are there in the JNCIA course outline. So what is routing policy? That first we will try to understand. Then we will see one practical example on this. So which will make this concepts pretty clear for us, hopefully. Guys, have you experienced routing policy in Cisco? In Cisco, it is not very frequently used, but here, in case of Juniper, we frequently use this routing policy. Right? As you can see from the diagram, uh, the routing table imports the routes from the neighbors, from the other protocols. For example, the routes imported from the OSPF, routes imported from the BGP, or routes imported from RIP, right? Or it could be imported from the OSPF neighbor or BGP neighbor, right? And uh, it's not necessary that if we have a static protocol, static routing protocol, static routes that will go into the OSPF protocol, it's not necessary. If you want that default static route to be exported uh, into your OSPF routing protocol, which gives the routes to another adjacent routers, right? So for that, we have to explicitly create an export policy. So there are some implicit policies and there are some explicit policies that we have to have a look on it. Okay. So we will see how this import and export policy works. So there are default routing policy. You can see import and export. Import policy, right, is coming from the other routing protocol to the routing table, and export policy going outward. So you can see by default BGP, OSPF, ISIS here accept all options is there. Means any other OSPF neighbor will provide you OSPF routes, and that will be imported into your routing table, right? That's not the same as for the export policy. And the export policy, it's not necessary it will go outside. For the LSA flooding, it is there, but for it's not necessary that every route coming from the other routing protocol will also go in through the OSPF to other routers. Right? So at the end of the this discussion, we are going to set up a lab like this, which is already running in my event. Sure. So same lab whose snapshot I have taken in the document, right? And here, this lab I have shown you for the OSPF practical case, and here I have manipulated the same lab a little bit to show you how it is working for the routing policy here. So what I have did in this case, I ran an OSPF. Let me note it down here. OSPF with area 1, area 0. So all of these routers are in the OSPF area 0, right? And they are sharing their routes, even including their loopback interfaces. Like here we have router 2 with the loopback interface 2.2, R3 with cord 3, and R4 with cord 4, right? R5 with cord 5. And here, believe here we have cord 1, right? And all are sharing their routes with this direct links 20.0, 50.0, 30.0, 40.0, right? And this VMX router do have a static route pointing toward R5. Let me show you that as well. So you can see here, I have a default route pointing toward 50.5. So who is a 50.5 over this link, 50.0 link? Here we have 50.5. Okay, this is my default route. And this default route via OSPF, right? I have OSPF neighbors. So OSPF neighbors. So I have 222, 333, 444, and 555 as a neighbor, means R3, R4, and R2 and R5 are the neighbors. So uh, through this OSPF, this default route is propagated to R2, R3, R4. Let's see on R2. So if you check the routing table of R2, so at the end or at the bottom of this routing table, we have OE2, means external route, right? And external route, you might be aware of, like it comes from the LSA type 5, right? And here the next stop is 20.1, and 20.1 is the IP address of VMX router. Same if you check on other routers, for example R3, here also you will see this OE2. Right. So here also we have 30.1 as the next stop, right? So all default routes are pointed toward VMX router, and this for this we don't have a static route, rather this is propagated by the OSPF. Means OSPF running on VMX is advertising the static route or exports the static route into OSPF, and OSPF will send it into other routers. Do you have any similar word in Cisco world for this kind of transmission, like a sending one protocol information into another routing protocol information? Correct. Ganesh has already shared this maybe. Redistribution, correct. Redistribution we use. Uh, so redistribution is used in Cisco terminology, and in Juniper we have the routing policy. Okay. So how we do this redistribution or how we do this routing policy on VMX router? Let's try to understand that, and then we will be able to map that theory with this implementation here on the Juniper route. Show configuration related to routing options. First of all, I'll show you. So here under routing options, I have a static route, default static route, and I have router ID which is used in the OSPF. Same thing we can check on the OSPF routing protocol. So under OSPF protocol, we have area 000, and under this we have all these four interfaces connected with router 2, 3, 4, and 5, right? Along with that, if you have noticed here, I have mentioned export DEFST. So this default static route, okay, is named as DEFST. This is up to us. We can give any name for this purpose. So I gave DEFST here, and what's there in that? So for that we have to change this flow configuration command. And so we have to see this with the policy option, not with the routing options. Policy options. So under policy option, I have defined DEFST. Under this, we have terms. So under term, we have from statement and then statement. Right? So if the protocol is static, and exactly speaking route filter 0.0.0.0, right? Then we are going to accept it, right? And we are going to export this into OSPF, right? And that's why this OSPF is going to Ganesh, yes, we don't have to do redistribution in case of if you want to achieve this task, default information originate is good enough in Cisco world, right? But if you have any other protocol, for example, if you have other protocol like a BGP, or if you have any other protocol like a RIP, right? Then we may have to use a policy options in that case. Okay. So this is what we have as the policy statements here in policy options, and we have exported this. We have exported this into uh, this OSPF here. Okay, let's see the theoretical aspects related to this. So the structure, we can give any name. So I gave DEFST. So we can give any name for this purpose according to the scenario. Then we have from statement, the term first term. Then whatever you mention, that if it is matches, then statement will be executed. If the match is not done on the first statements, then it goes to the second terms, right? And whatever is there in the from statement, if it is matched, then will be executed. And if it is not, then the default statement or the third statement will be there, right? So here we have few more things about the routing policy, like there is a and statements and or statement included in it. The terminating actions will be either accept or reject, right? And what matching criteria we can set? In our case, we have taken protocol, and we can set it on the basis of next of, we can set it on the basis of neighbor, we can set it based on the route filters. So we have used two match criteria. One is oh, static, and the other one is route filter, if you have noticed in this case right here. So protocol, static, and filter exact, and this is kind of and statements we use to, means we want both of them to be there, right? And if it is a or statement, then either one of them will be accepted. In case of route filters, we can have exact match. So here in our case, we are taking exact. We could have or longer. We can have longer, or we can have up to. We can have prefix length range. From the graphics, you can understand exact means exact one network, or longer means from 16 onward up to 32, right? And longer means except 16 onward, whatever is there that will be accepted. Up to means particular statements, right? Like up to 16, here from 16 to 24, like this. So we can go for exact matchings, or the range matching as per our requirements. So the configuration goes like this. Let me note down in our document. This full statements are little difficult to understand, so I'll use this with the display set. It will give us better representation documentation. We can go one by one. That is also possible. We can take policy options like this. Under this, static routes and the router ID is important. So only that I mentioned. So the next task under this is about firewall filter. So these firewall filters are stateless firewall filters. Do we have any similar concept? And give me a 2 minutes, 1 minute. So firewall filter concept is there in Cisco in Juniper routers. Is there any similar concept we have in Cisco routers? If you take Cisco routers and if you implement ACL, is it stateful or stateless? Yes, it is stateless, right? So if you implement BSRX firewall, right, there we have a stateful inspection. If you implement Cisco ASA firewall, then that uses a stateful inspection. But normal Cisco router, ISR router or ASR router, there we have provision for stateless firewalling in the form of ACL. And here also we have firewall filter in the form of stateless implementation, right? Before that, let me show you one more thing in our practical. So I have kept one router outside of the like this domain, OSPF domain, right? This network is a cloud zero, means it is connected with 147.0 network, 192.168.147.0, and I have kept R5 as an edge router connecting to the internet. Let me show you what I configured here. So here I have a DHCP based IP address 147.139. This is going, this is connected to the NAT network here. Furthermore, this 3725 is also connected with this NAT network. So here we have 147.140, right? And in case of R6 router or this last router, I have created one static route. Uh, 50.0 is toward 147.139, which is the IP address of R5. Because here we have not implemented NAT, right? So if the packet comes from this network and if it goes to 3725, you will not get a reply. Why? Because this 192.168.50.0 will be unknown to 3725. But if you put a static route, then it will be accessible, right? So if you try to access through the VMX router, if I try to ping 192.168.147.140, okay, so we are getting a reply. Reason, we do have a static route pointed back, right? So VMX router has a default route to R5 and we have a default route from R5 to the NAT network, but this is not about the default network. This is a direct connection between R5 and this 3725. That's how we are connected. But if you try from other network like 20.0 or 30.0 or 40.0, then it will be difficult to access it because we don't have any static route available for 20.0, 30.0, or 40.0. If we add that, then from R3, R4, and R2 also, we will be able to access this 3725 outside of our OSPF domain. Right? I was trying to implement NAT on R5, not R5, the VMX router, and I was trying to keep this VMX in the topology on the edge router, but VMX showing some issues to implement NAT. VSRX, I shown you yesterday, it was working very fine with the NAT. Right? And either with the JWeb, it is very simple to implement, and with the CLI also, we have seen the configuration. Uh, did I share the Google Drive links? Can you share the Google Drive links? I have kept it at multiple places, so I forgot where I kept it. Let me check. I think I have not shared from this one. Okay, so I think this one is the Google Drive link that I shared with you. On the same folder, let me upload the Google documents that the documents that I have created for this JNCIA training. Share with you. But I have to make it a PPT first. So let's the PPT of this. And this is a version 1. Actually, I'll make few more changes and I'll make, but for the time being, let's put it this. So like this, I'll upload the rest of the documents also. And firewall filters, guys, that we will cover up in tomorrow's session. And one more topic that we have to pay attention on tomorrow's session is about uh, Unicast Unicast reverse path, right? So that is used for the security purpose. That also we will cover up tomorrow. Let me exactly what topic it is. Let's not this one. Not this one. Tomorrow we'll take a review and complete rest of the points. My internet is little slow today. I hope this Google Drive is still accessible to you. Right? by today or by tomorrow. I'll upload rest of the PDF files, right? And this will be like a version one. Rest of whenever I'll put updates, I'll update in the same Google Drive. One, if you have this Google Drive link, guys, please share it, or else I can share it from here. That is also possible. Okay, Nazik, I have shared this. So network fundamental, noise fundamental, user interface, right? Configuration basics, then operational maintenance, right? Routing fundamentals, and routing policy and firewall filters. Among this, unicast, reverse path forwarding, and firewall filter. These two topics are remaining that we will cover up in tomorrow's sessions. And tomorrow, if possible, we will take a review of all the topics, or we can have a question answer sessions for this. That's it, guys. We are done for the day. If you have any questions, you can ask. We can stop our session. Okay, then. See you tomorrow. If you have, if, even if you have a questions in tomorrow's session, you can ask. But most of the things are pretty clear. Right? Our videos are also uploaded. You can go through it for the recorded session, and you can share with your friends if you have the similar studies. If you have your friends are also doing the same studies on Juniper subjects, will be helpful for them also. Okay. Okay, guys. Bye.